So, first of all, if you are going through this grad school process, Leland is a great place to be. They've got all sorts of these kinds of free events and stuff. So, if if free advice from experts is kind of your thing, this is definitely going to be something that you're going to want to. You just want to sign up on, and that QR code right there is going to be very helpful for you. And you know what? Okay. So here's what we're going to do. I'm going to tell you a little bit about me, and then we're going to do some overview, and then we're going to do some mixtures and solutions, frameworks, and a bunch of examples, and then a little final word. So this, I promise, is the least interesting of all the slides in the presentation. This is a little bit about me. I've been teaching GMAT and GRE for a long time, both at UCLA. I formed my own company, and now I'm doing it here at Leland. And here's the thing, and I kind of want to address the elephant in the room before we start. If I had a show of hands, I'm sure every single hand would go up if I said, is this business about applying to business schools? Is it harder, longer, more stressful, and frankly, more lonely and uncertain than you could have ever dreamed of? I bet every single hand would go up. And here's the thing. It is hard, and it really, really undermines your confidence. If you're interested in some help, the Leland coaches here are incredibly experienced. They've done it, they've applied, they've all gotten into great schools. Most importantly for you, they've helped other people do it. And it really, really does help if you have an expert who is on your side. So here's what we're going to cover today. So let's dive in. So we're going to talk about the essential frameworks for mixtures and solutions, and we're going to do a lot of practice questions. So here's the thing. A common mixtures question would be something like this. Kathy's Candies sells chocolate creams and chocolate covered caramels. If the creams sell for $5 per pound and the caramels sell for $9 per pound, how many pounds of creams would be in a 10-pound mix that sells for $8 per pound? And some of you out there are saying, well, hang on, can't I just do this as kind of a regular average kind of thing? And you could put it into kind of, just a mean, kind of framework, and it would work just fine because we have all the things we need to calculate the average, right? We have the average total price, it's $8. We have the total number of pounds, it's 10. We have the price of creams, we have the price of caramels, number of pounds of creams, that's what we're being asked, that's X. But we can also express the number of pounds of caramels in one variable as well, 10 minus X, because if the total number of pounds is 10 and the number of pounds of cream is X, then caramels must be 10 minus X. And this is something that comes up a lot. If A plus B equals the total, then the total minus A equals B. And so you're not wrong. You're saying, look, can I put all this information into something that looks like, the way I normally calculate an average, which is always the value of things, or the number of things times the value of things, the number of things times the value of things over the total number of things equals 8. Yeah, equals the average. You bet you could. And when you do this, right, we could just multiply the 10 through, you're going to get an equation that looks like this. And this form of the average, kind of equation, super helpful when it comes to mixtures and solutions. Because if we take a look at this, what we've got is we've got thing one. We have the value of thing one times the amount of thing one. Thing two, the value times the amount of thing two, and that equals a target, which is also the value times the number or the amount. This framework is super, super helpful when you're doing mixtures. Okay, I'm actually going to pop out. I'm actually not able to see you guys, so I'm going to pop out of the sharing real quick here. Okay, and go here. I just wanted to make sure, can everybody see my screen? Are there any technical issues that anyone's having before we move forward? Okay, so looks like everything's good. All right, we'll continue the sharing. I'm sorry, I'm not going to see, there's some technical issues going on, and I'm not going to be able to see questions, but we'll just keep moving on, and I'll just try and be as clear as possible. Okay, so let's go ahead and share, and we will be off again. All right, here we go. So this is a very, very convenient way to look at, the doing mixtures and solutions, because this framework, it ends up basically laying right on top of how they ask the questions. So let's go back to our Kathy's Candies, and this thing becomes very easy to set up if we use this framework. So what we're being asked for is, well, we know that the value of creams is $5. We know the value of caramels is $9, and we know the target value, right, is $8. All right. And then we know that the total target, right, total amount that we're going to be left with is 10 pounds. We're being asked for creams, and we know caramels must be 10 minus X. And this becomes a very, very simple, formula there. It's a pretty simple equation. Boom, X equals 2.5. Okay, so let's take a look at another one. So Bruce's Awesome Coffee is making a new blend, which consists of premium Colombian and regular house. Premium Colombian costs $10 a pound. Regular house costs $4 a pound. How much Colombian should the company use to make 100 pounds of coffee, 100 pounds of a coffee blend that costs $5.50 per pound? Okay, so first thing we're going to do is we're going to identify what the heck we've been asked to find. The great thing about having a framework like this, look, they can only ask you one of 6 things. That's it. And in this case, we're being asked how much Colombian. So that's our X. And then we know the value of Colombian, $10 a pound. We know the value of house. That's just $4 a pound. And we know a lot about our target. We're trying to make 100 pounds that cost $5.50. So what this means is the only thing we need is the amount of house. And we know that if we made 100 total pounds and X pounds of it are Colombian, house must be 100 minus X. Bing, bang, boom. We have a very simple equation to solve. And we just solve that down. And we find that X is 25. All right. Let's take another one. And this is, kind of trickier English, right? Because as you guys have probably done a bunch of these, this isn't necessarily about math. The math is pretty straightforward. This stuff is really about getting their tricky English into, a framework like this. Okay, so the first part of a tournament, a card player won 60% of the games she played. Pretty good. During the rest of the tournament, she won 3 out of 20 games. If she won 40% of the games she played, how many games did she play in the tournament? Okay, so we know that the value of part 1, she was 60 over 100. She was on fire. Value of part 2, she won 3 out of 20. Target, 40 over 100, right? 40%. So what about the first part? How many games did she play? How many did she play that she won 60%? Well, we don't know. Call that N. And value 2, we do know. She played 20 games. Won 3 out of 20, so we know part 2 was 20 games. So the target must be N plus 20. The number of part 1 plus the number of part 2 always has to equal the target number. So there we go, just like that. We have a relatively simple equation to solve. My thing is I hate denominators. So whenever I see something like this, I'm going to multiply everything through by 100 to get something that's a lot easier to deal with. And then boom, boom, and we find that N equals 25. Okay, let you guys absorb that just for a second, and then we'll go on to another one. All right. Oh, I'm sorry. Oh, I almost blew it here. So keep in mind exactly what we're being asked for. We were not asked for N. We were asked for the total number. That's N plus 20. Yeah. So again, it's the English that messes you up. It's rarely the math. Okay. Another one. So notice when we're doing mixtures, there are a whole bunch of values, right? There are a whole bunch of things we can mix, right? We could mix dollar amounts. We could mix the number of games you've won and lost. In this case, we're going to mix test scores. So the average mean of N test scores is 80. The average mean of the original n test scores plus an additional test score of 85 is 81. What is the value of n? Okay, I don't know what any of that means, but we have, I know that original plus added score has to equal the target score. And so we have a framework and we can put all of this information in and it's going to become a lot clearer. So first of all, n test scores. The original, we have n number of them. And we know that the average, the value of those was 80. Okay. Then we know that the added test score was 85. And we know that we have one of those. So that means the target must be 81, right? Because that's the average. If you average the original plus the added score, it was average of 81. And we know how the number of them. It's got to be n plus 1. The number of the original plus the number of the value has to equal the number of the target. And boom, we end up with a very, very simple equation to solve. And this time we are being asked for n, and we can find n. Okay, good job. Let's talk about solutions. Solutions work pretty much exactly the same way as mixtures. The only difference is kind of what we're going to label everything. Instead of kind of thing one blended with thing two equals a target, usually they start us out with like some sort of original amount and some sort of original solution, and then we add some amount of another solution to get a target solution. So for solutions, because look, we're always dealing with averages, so we always need the value and we always need the number of things. So the original in solutions is always, the value is always some percent or some ratio. The added, same thing. It's going to be a percent or a ratio times the amount. And the target is going to be a percent or a ratio times the amount. Okay, well, let's take a look. So for number one, we've got how many gallons of a 10% antifreeze solution need to be added to 40 gallons of an 80% antifreeze solution to create a solution that is 50% antifreeze. Okay, well, let's take a look at this. First of all, what the heck are we being asked for? We're being asked for how much we need to add. That's what we need. We need the added amount. What are we starting with? Well, we're starting with 40 gallons of an 80% antifreeze solution. I'm going to write 80% as 80 over 100. And then added to that, we have some amount of a 10% antifreeze solution. So X is what we're looking for. 10 over 100 is the percent. And then our target is we need a 50% antifreeze solution. And how much of it will we have? Well, we have our original 40 gallons, right? That didn't go anywhere. And then to that, we're adding X. So we must need 40 plus X. Remember, the amount of the original plus the amount of added always equals the amount of target. And just like that, to multiply through by 100, and just like that, we have a pretty darn easy equation to solve. And X is going to equal 30. Okay. And for most of these, if you're, I'm going through the algebra pretty fast because look, most of you guys are going to be able to solve the algebra in 9 seconds. That's not going to be that thing. It's really setting these things up. That's where the action is. Okay. Let's take a look at something, at another one. So what concentration should 4 quarts of salt water have so that when it's added to 5 quarts of 40% saltwater solution, the resulting solution has a saltwater concentration of 33 1/3%? Are you kidding me? It's just, it's just word soup, but that's what they kind of rely on, but that's why we have a framework so we can sort all this out. So first of all, what are we being asked to find? Well, we're being asked to find the concentration. So we need to find the percentage here. And we are adding some concentration. We don't know what percentage we're adding, so X over 100, but we're adding 4 quarts of it. And we're adding that to 5 quarts of a 40% solution. And that target solution needs to be 33 1/3 over 100. And we are going to end up with 9 quarts of it. Because 4 plus 5 equals 9. The original amount plus the added amount always equals the target amount. And just like that, okay, now we have an equation that's really relatively straightforward to solve. And so we just keep on solving it down. And what we find is x equals 25. Okay. I just need to check something real here. Okay, great. Let's go on to another one. Let's talk about a game that they play with solutions. Now, here's the thing. On these solutions, we have a percent, right? That's our value, our percent. There's no difference between a percent, a ratio, and a fraction. And because there's no difference between a percent and a ratio and a fraction, when it comes to solutions, they can start playing ratio games on you. And here's how it works. If you're given one ratio, you're actually being given three ratios. This is super important. This comes up all over the test. So for example, let's say you had a pie contest and you had cherry and apple pies entered into the contest. And they were entered in the contest in the ratio of 3 to 5. Well, if there were in fact 3 cherry pies entered in the contest and 5 apple pies entered into the contest, the total number of pies, the total would be 8. So that means cherry over total is 3 over 8. Apple over total is 5 over 8. I should mention this only works if you have 2 variables. If you have more than 2 variables, this doesn't work anymore. This one ratio is 3 ratios doesn't work. But guess what? We're in the land of mixtures and solutions. It's always 2 variables. So here's what that means. That means they can start you out with this ratio, but that's not the one they need. That solved the problem. You need this ratio. And they can expect you to go from that first ratio to the last ratio because they'll expect you to know that when you've been given one ratio, you've actually been given 3 ratios, which begs the question, okay, Bruce, okay, got that. How the heck do I know which ratio I'm supposed to use? Well, let's take a look. Let's go back to our antifreeze example. How many gallons of a 10% antifreeze solution need to be added to a 40 gallons of an 80% antifreeze solution to create a solution that's 50% antifreeze? So the first thing I want you to do is look at this and say, do you know what? This whole question, it's about antifreeze, right? And look at what our ratios are. Our 80% antifreeze solution, that's 80 over 100 is antifreeze to total. A 10% antifreeze solution, that's 10 over 100 is antifreeze to total. And we need to create a 50% antifreeze solution. 50 over 100 is again antifreeze over total. So whatever the question happens to be about, and in this case, this is about antifreeze, you need antifreeze over total. Whatever it's about over total. That is your target ratio. So we're going to do one where they give you the wrong ratios, and you got to use this 1 ratio is 3 ratio deal to get to the right ratio. Let's take a look at that. So the optimal blend of synthetic motor oil for a Formula One race car is a mix of monocarbonate and biglyceride in a ratio of 4 to 1. I have no idea if that's true. If the engine currently contains 20 ounces of synthetic oil that is 30% biglyceride, how many ounces of monocarbonate must be added to the engine to achieve an optimal blend? Okay, I don't understand any of those words, but not understanding the question is no excuse for not getting the question right because we have a framework. So the first thing to notice is that we're adding mono. So this question is about mono, and we need to know how much mono we need to add. Okay, well, I think for the target, what we're told is we've got mono and bi in a ratio of 4 to 1. Well, now, do we need the ratio mono to bi? Is that the ratio we need? No. We need mono over total. Every single one of these ratios has to be mono over total, but that's okay because we know that when we have 1 ratio, we actually have 3 ratios. So mono over bi is 4 over 1. That must mean mono over total is 4 over 5. That is what we use for our target. Every single ratio has to be mono over total. Okay, so let's do the original. So the original is a 30% biglyceride. So biglyceride over total is 30 over 100. Do we want the ratio of biglyceride over total? We do not. We want the ratio of mono over total, and that's okay with us. One ratio is three ratios. No big deal. If bi over total is 30 over 100, mono over total must be 70 over 100. So 7/10. Okay. And then we know that we already have 20 ounces of this stuff sitting in the tank. The engine currently contains 20 ounces. Good. So then we need how much of the mono, and this they do. We're adding straight monocarbonate, right? We're not adding some percent. We're not adding some watered down solution. It is straight 100% mono. Look out for that language. They like to use it. Don't be fooled. It just means it's 100% or 1, which means that the target is going to be 20 plus X. That's going to be the amount, because the original amount plus the added amount always has to equal the target amount. And boom, we have ourselves a linear equation. You can solve that down however you want, and you're going to find that X equals 10. That's about as tricky as they can make it. So it's this idea of blending these ratio rules, right? One ratio is three ratios, giving you basically a bunch of words you don't understand, and giving you the wrong ratios, right? Very, very tricky stuff. But as long as you are patient and put it into the framework, as long as you have a framework, you're going to be fine. Just keep in mind which ratios you actually need. Make sure you have those ratios. All right. There's one other kind of trick they can play. Actually, there are two others. This is the tricky one, and the other one's really simple. You guys are going to love it. So what they can do is they can actually do a substitution. In other words, it's like you got a full box of Cheerios. We're going to pour out some of the Cheerios, and then we're going to replace some of those Cheerios with like Lucky Charms, right? We started out with one box. We still have one box, but the new box is part Cheerios and part Lucky Charms. So when we have basically a substitution, it's the same framework. We basically just build it backwards. Here's how it works. So Raul has a full bottle of a half caffeine, half decaf coffee drink. He replaces part of the original drink with 25% decaf. If the resulting drink is 30% decaf, what percent of the original drink was replaced? Okay, well, let's take a look. So this whole thing isn't about caffeinated coffee, it's about decaf, right? Because that's what we're replacing with. So this thing is about decaf. So we start with the target. The target percent decaf, 30%, right? How much of this do we have? Well, we started out with a full bottle, and guess what? At the end of it, we still have one full bottle. We didn't add any, we didn't subtract any. All we did was substitute, but we started with a full bottle. We ended with one full bottle. Okay, let's talk about the substituted. What was the percent, right? What's that ratio? We don't know how much we put in, but we know that it was a 25% solution, right? That's what we put in. And then the original amount of decaf, well, that was a 50% solution, right? Because it's a half caffeine, half decaf. So that's 50%. After we've done these substitutions, how much of this stuff do we have left in the bottle? We started out with a full bottle, right? But we don't have a full bottle anymore. We poured some out. We poured some of this 25% solution in. Well, it must be 1 minus X. That's how much of the decaf we have left. And if that's a little hard conceptually to get your head around, you can always use the framework to help you, which is the beautiful thing about frameworks. We always know that the number of the original plus the number of the substitution has to equal the number of the target. So 1 minus X plus X equals 1. That will always be true. That will always get you out of trouble if you're a little unsure about how all of, this idea of, this 1 minus X thing, if you find that a little elusive. Okay. So there's, we can do Oh, and we obviously just solve down then for X because we have a very simple solution. Okay. We can do the same thing. Let's try another one here. Construction supply company delivered 100 pounds of a gravel cement mix to a client, and this thing was 2/5 gravel. Fortunately, the client required a mix that was 80% cement. How much mixture must the company remove and replace with cement to meet the client's requirements for the 100-pound delivery? Sounds a lot worse than it is. They always do. So, first of all, we're being asked for how much cement we need to substitute or replace. The target, we need an 80%, right, cement solution, basically, right? Now, how many pounds of it? 100. 100. What was the substituted value of the cement? Are we putting in some kind of like watered down, percentage of cement? No, we're just adding pure cement. That's 1. So after the substitution, hang on, what did we have? To begin with, we had a 2/5 gravel. So gravel over total was 2/5. Is this about gravel? No, this is about cement. Did they give us the wrong ratio? Yes. Do they like to do that? Yes, they do. Don't know what's wrong with these people. They were not held enough as small children. We don't know, but that's the deal. So, but that's not a big deal for us because we're just going to convert it into cement over total, which is 3/5, right? So, or 0.6. How much? Well, 100 minus X. Now we have a very, very simple, very simple linear equation to solve. Boom. X is going to be 50. All right. One more. And these actually sound bad, but they're so easy. We really like these. So a scientist needs to create a solution that's 40% of compound A. Unfortunately, the lab only has a bottle of 20% compound A solution and a bottle of 50% compound A solution. In order to create a 40% solution, what percent of the total solution would need to be the 20% solution? Okay, well, we have a framework here. Let's kind of we're going to have to, assign some variables here. Let's say X is the amount of 20% solution we're going to use, and Y is the amount of 50% solution. Notice we've been asked back for a ratio. We've been asked back for X over total. X over total. It's exactly what we've been asked back for. We love being asked back for ratios because whenever, and this is true on mixtures and solutions, it's also true darn near everywhere else on the test. When you're being asked back for a ratio, you get to use 2 variables. I'll show you how this works. So the first solution is a 20% solution. How much of it do we have? We have X. And to that, we're going to mix a 50% solution. And how much of that 50% solution are we going to use? We're going to use Y. And what's the target solution we're trying to make? We're trying to make a 40% solution. And how much of it are we going to have? X plus Y. And I know some of you are saying, hang on, wait a minute. How am I supposed to solve for X now? How am I supposed to solve for Y? We don't need to. We just need to solve for the ratio. And that gives us a huge advantage. So that means 0.2x plus 0.45y equals 0.4x plus 0.4y, right? Just multiply the 0.4 through the parentheses. We do a little bit of combining. We get 0.1y equals 0.2x. That, my friends, is a ratio. And that is our best friend. We love ratios because that means x over y is 1/2. Remember, you should be able to cross multiply that back out and get 1y equals 2x, and we sure can. Hey, if we've been given 1 ratio, have we actually been given 3 ratios? Yes, we have. X over total is 1/3. Just like that, we take what they consider a very hard and very intimidating question, but we love it. We're just being asked back for a ratio. Okay. 30, and yeah, right, they need a percent, so 33.3%. Okay, that's what I got for you today, guys. I really hope that it was helpful for you. If you are interested in working together, I'd love to work with you. So there are a couple ways we can work together. My regularly hour rate, if you just want a couple hours, maybe go over a practice test or something, is $275. If you're interested in more time together, I do offer discounts for 5, 10, and 20 hours, and that is $250 per hour. And that's what I've got. And I really appreciate you guys taking some time out of your day and sharing it with me and doing Mixture Solutions of all things. But great work, guys. And if you're interested in working together, just oops, just reach out. Just reach out anytime. All right. And we'll see you later. Bye bye. Oh, someone has a question. Yeah. Oh, in the chat. It's in the chat. Okay. So, yeah, if you have a question, throw it in the chat. And I'm looking for it. I'm looking for it. Someone said thank you. You're very welcome. Okay, guys. See you later. Bye bye.